So since the 1990s, no other technology has had economics working for it like batteries. I mean, we're talking about 100% drop in price since 1991. This absolutely dwarfs the 55% and 89% reduction in costs for wind turbines and solar PV, respectively. I think that the future of energy is incomplete without batteries.
Crispy Perspectives. Hello, everyone, and welcome to another episode of the season 2 of Crispy Perspectives. In this season, we discuss the future of energy. I'm Sahil, your host for the evening, and today with us we have our very own energy connoisseur, Kedar. Kedar, welcome to the show.
Thanks, Al. Thanks for having me.
Today is an interesting episode because this discusses one of the most important components of our whole energy landscapes. Today we talk batteries. And what better of a time to talk about batteries than now? Typically because we are at crosshairs with multiple technologies all evolving at the same time, especially batteries. And to take ownership of the way it's evolving and to see how the batteries are going to create an impact in all of our lives. So we have talked a lot about batteries. Kedar, what are batteries? Are they responsible for generation or consumption or what? Both?
That is the poignant question of the moment. And I think the answer is going to be a fuzzy yes/no. Batteries are simultaneously not going to be classified as either generation or consumption, but they fall into this gray area between both, where you are able to store generation and then shift it to consumption that is happening at another time.
That's valuable to know. But Kedar, if we are talking about batteries falling in a gray area between generation and consumption, are all the batteries in this gray area or are there different kinds of batteries?
In answer to your question, yes, all of these batteries are in the same areas, but you do not have just one type of batteries. You do have different classifications of batteries, and the most or the largest of them are one, mechanical. So, mechanical batteries which then store electrical power or convert it into kinetic energy and then release it or convert it back into electrical energy. You have thermal batteries which play with converting electricity into heat. And finally, you have chemical batteries which then make use of chemical reactions to store electrical energy.
Great. I also understand that various batteries have various applications, and I think chemical batteries is what would be the AA and AAA cells which we generally use in our day-to-day applications. Is that correct?
Absolutely. And so chemical batteries are where you have, for example, the classical terms like anode, cathode, or the different types of chemistries like LFP and NMC.
LFP or lithium ferrophosphate, also commonly known as lithium iron phosphate battery, as well as NMC, which is the nickel manganese cobalt battery, are some of the popular upcoming battery chemistries in the battery markets across the globe. Right. And when you mentioned mechanical batteries, Kedar, I think there was this movie which I watched called as Sniper the White Raven. In this movie, in the very first few scenes, I remember that the protagonist is a professor and his wife at home creates a different kind of a battery where she has a pulley system where she hangs a weight by the pulley and then releases the pulley that drives a dynamo of sorts. And because the dynamo starts rotating, there is energy which is generated and a light bulb is powered by it. So I think this is what you would qualify as a mechanical battery. Is that correct?
Yes, absolutely. And in more specificity, that becomes then what is called a gravity battery, because you pull a load up and you have a high amount of potential stored, and then you allow gravity to do the rest as that potential energy is then converted into kinetic, which is then used to rotate the dynamo. I think another application of a mechanical battery falls under what one of the biggest sort of sources of energy storage we have in the world today, which is called pumped hydro systems. which then uses the power of water stored in a higher level to then convert it into kinetic energy as the water flows down to a lower level, use it to rotate turbines and then generate electricity.
That's encouraging to know that we have batteries beyond chemical. I think when I started earning and I had the first few paychecks in, the biggest or the most proud purchase I made was that of an automatic wristwatch. I remember having it around and it did not have a battery in it. The way it worked is it had a coil, and that coil would wind itself when you just have hand movements, etc. In a case where you lack a battery or a chemical battery within the housing of this mechanical watch, this coil acts as your battery. So again, is this another example of a mechanical battery?
Absolutely. And I've never had the fortune of owning a mechanical watch, but I think that is one of the most amazing applications of storing energy and then releasing it over a larger period of time that I've ever seen. And also with the benefit of not having to use any chemicals, so it's also very, very safe and less polluting.
Oh, yes, indeed, it is less polluting. But then there are the downsides to it. Typically, one, the coil has a particular spring coefficient, and we have to, of course, go back to the service center again and again to ensure that the spring coefficient is maintained and it is not overcoiled, or the lubrication within the jewels and every other part within, because there are multiple moving parts. The battery per se should work. I think you are not an analog person from what I know you of. You are a tech guy with a lot of tech around you. So I don't think an analog mechanical watch would work for you. But the battery that we talk about, it has a certain energy, right? The spring coefficient I mentioned was also energy coefficient in some sense. And in the first episode, if I recap, you gave us a very nice explanation of what is energy versus power. Can you also dive a bit deeper and probably create a more visual picture of what is battery power versus battery energy?
Yeah, a beautiful question. In very, very short, what I can summarize is that power is to energy is exactly what temperature is to heat, right? One measures the intensity or the rate at which something is delivered, while the other measures the quantity or the volume at which something is delivered. And so when you're talking about batteries specifically, batteries are usually having a rated power, and you measure the power in terms of watts or kilowatts or megawatts and so on. It is basically the instant amount of electricity that it can deliver. So the rate at which that electricity is delivered, for example, per second or per minute or per hour. And then when you aggregate all of this over time, over let's say seconds or minutes or hours, that quantity then becomes energy that is measured in watt hours or kilowatt hours.
That was a very picturesque explanation of a versatile way in which we can define battery power versus battery energy. But also, if we dive a bit deeper, I understand that every single battery that we talk about has a particular application for a use case. Today, I mentioned 2 or 3 use cases to you, right? There was one use case with a gravity battery, as you mentioned, one use case with the water pump converted to a battery, and then I mentioned my mechanical watch, which had a spring as a battery. Can you give some specific use cases which have not just empowered individuals but also communities?
A very, very beautiful question. Yes, there are lots of use cases where batteries have been supporting not just individual households or individual groups, but rather larger groups of communities. And I think one brilliant example is what's happening in the West Australian power grid as of now. Or Australia in general is a large source of solar power, so which means you have lots of sunlight and so lots of potential to then generate electricity from solar PV. But you always have generation that is happening at one specified period of time and consumption that is happening in a different period of time. And so West Australia or the West Australian power grid has been this perfect sort of testing ground, breeding ground for installers, for manufacturers to go out there and install large scale batteries. So we're talking about batteries that have capacities not in kilowatts or even megawatts, but rather in gigawatts, which means that one single battery can supply millions of homes with power. And these batteries have been doing such a fantastic job that the Western Australian power grid has been one of the most famous grids that have been running over long hours completely on energy that is produced by renewables. And so this would not have been possible without batteries. And that's, I think, the difference that batteries has made to supporting large groups of peoples like communities and villages.
Kedar, I think it's very robust to have batteries to power grids which are enabling communities to have energy for longer. I would like to just shift our episode a bit and talk about the future of this species as humans, right? Humans are always talking about we want to go to space, we want to do space exploration, want to set up houses and housing colonies on other planets like Mars, etc. Do you think batteries play a major role over there as well? What do you see batteries in the future of humans as a species?
A very riveting question, Sahil. And to be frank, the opportunities are multifold and multidimensional. I think we're fortunate to be at a very early phase of battery technology, innovation and development and deployment in large scale, where we see batteries being rolled out and being utilized for the first time as a part of an energy grid. Of course, when it comes to humans moving away into the far future to other planets, the potential of generating, for example, electricity from renewables decreases, especially solar PV, but the fundamental of the battery remains the same. If you have a mismatch in terms of generation and in demand, you can always utilize the storage system as a buffer. And there I always see this basic potential of a battery being the pillar of support for humans into the far future. Now, around this, you build multiple different levels of use cases which then unlock the value potential of battery systems. But I think that fundamental core remains the same.
So, what you mean to say it would be moronic and idiotic for anyone to assume that we can have a future without batteries? If I were to just even have a lucid dream of a pioneering future with technology the way it is growing, batteries are at the forefront of this innovation. But how did batteries become so important to the current state of affairs, Kedar?
It's a fantastic topic to talk about because even 10 years ago, batteries would not even have been part of the discussion when you talk about energy or energy mix or energy sources. But what happened over the last 10 to 20 years is fascinating. You have a group of technologies, energy generation technologies, whose value of generation, the cost or the economics of generation has reduced so drastically, it would be nonsense to not move ahead with them. I'm talking, of course, about renewables. And you have more and more countries responding to those economics of scale by massively bringing in these sources to generate power. It also helps to the fact that these are also low carbon energy generation sources, which means you're doing good for the environment. And so on one side, you have now the capacity of renewables, the installed capacity of renewables going up in almost every single energy grid in the world. But on the other hand, you also have demand that is going up, right? People consume more and more electricity, and this demand is sort of in a cycle, which means that you don't have the same demand at every point of the day, but rather there are periods of the day where you have outsized demand and there are periods of the day where you have no demand or lesser demand. And usually humans, when they are at homes, it's usually during the early mornings when they wake up and then they prepare for in order to go to their offices and schools, and that's where you see a peak, an energy demand peak. And then once they are back home during the evening, they then prepare for the next day and they relax at home. That's where you see a second demand peak. And so you see that this demand peak is pretty much common. It's more focused towards the starting and the ending of the day. It's increasing. And on the other side, you have renewables which are increasing. And the funny thing about renewables especially is that they generate a lot of energy during the daytime, which means that you have, let's say in the afternoon period, a massive input of energy generation, but no one to consume it, which means that you are going to have grids that are being overloaded with electricity, but nowhere to supply it. And that is where the batteries come in. The batteries act as a buffer. They can then help capture this excess energy generation and then utilize it later on when people return back to homes, when there is especially no solar on the grid, and then make use of this electricity, this low carbon electricity that's been generated. And so we see that over time, over the last 10 years, as more and more renewables have been installed in countries, this volatility in generation coupled with the mismatch between the generation and the demand times is what has really proven to be the secret sauce for the introduction of batteries. And that's how they've become so important to the current state of affairs, that no government, no country, no energy grid in the world which is focusing on renewable energy can go without thinking about batteries.
That was heartwarming to know, Kedar, and your compelling argument is very convincing. there is no replacement for batteries, and in the future we cannot just imagine a future without batteries, right? Now let us come down to the applications, and not just talk about applications in terms of technology, but applications in terms of the use case. So what are the different scales of batteries, and what are their respective users?
Elegant question, Sahil, and I think batteries are highly dynamic in the ways in which they can be implemented, the ways in which that they can be executed to serve different purposes for different end groups. Batteries are also split in terms of three broad battery types. You have, on the very, very low level, the household batteries. These are batteries that are primarily used to take care of the needs of a private household, or let's say a group of households. And so the batteries that you talk about here are very, very low in terms of capacity, but they are then focused towards making sure that the user is able to be self-sufficient. Much more so when the user has a renewable power plant like a rooftop solar installed on top of their home. On the second level, then, you have what are called commercial and industrial batteries. And these are batteries that are again tailored towards satisfying the needs of either a commercial space where you have office spaces, people working throughout the day, 5 days a week, or industrial spaces where you have shift based work, which is then 24/7, where you then need the battery to then support, for example, large industrial machinery. And on the third scale, this is the biggest scale of all, you have batteries that are called grid scale batteries or utility scale batteries, which are then used to be a backup for electric grids. So in case a grid is becoming more unstable, you have batteries that provide what is called as balancing grid energy, ensuring that the grid is stable. And on the other hand, you also then have these big scale batteries which are used to then satisfy the energy demand for thousands or even millions of households.
Wow. So you mean to say that because the energy demand is rising at all levels, we need to ensure that there is energy security, and this energy security can be ensured through batteries. Totally understood. But while we are ensuring that we are putting a lot more batteries on ground for all of our applications and the purpose of energy security, we need to also look at the sustainability angle. The world is now wanting to move to net zero. People across the world are working towards it, and countries are taking oaths to ensure that the net zero happens. But can batteries actually substitute for these polluting energy sources?
A very poignant question, a very good assessment, but I think it's a bit flawed because, again, to reiterate, a battery cannot be classified as a generation source because you are not generating energy from the battery. You are only storing energy that has been generated elsewhere and then buffering it to a later point of time where you can consume it. That being said, I think batteries do come with their own set of issues. They are, of course, made with minerals and materials that are extracted from the ground, and so they have to then also be looked at in terms of how much emissions they're emitting per kilowatt hour, and also the cost of the battery that is also fluctuating in terms of market factors such as supply and demand also will then have to be taken into account when choosing to invest in batteries. But ultimately, when it comes to your question, can batteries substitute for polluting sources or whatever polluting energy resources are? I think it comes to them acting as a buffer, right? So either you act as a buffer for a power plant that is generating energy using coal, or act as a buffer for a power plant that is generating power using the sun's radiation.
I understand, Kedar. Maybe my argument was a bit illogical and my question was maybe a little ill conceived. We should now focus on the grid that supplies to the battery rather than the battery. Because if the grid is clean, the battery is going to store clean energy. If the grid isn't clean, the battery is going to just act as a buffer for highly polluted sources of energy, right? So coming back now and just talking to the battery sort of a environment, I also work with electric vehicles a lot, and their batteries, they die. So I also understand that fundamentally all batteries are going to die eventually, right? No battery is a forever battery. Or maybe it could be, you could correct me there, but I understand that batteries die. So what about the death of batteries? In a few years, if we were to create these huge battery grids, these batteries are going to need replacement. And the capital investment is very, very high. So is it a financially feasible option to keep replacing batteries after every few years? Or is it financially feasible to just set up a very large energy source like a power plant, but it may be then polluting?
A wonderful question. Let's look at the basics first. Right? There is no doubt that batteries are going to play a huge role, which means that as we bring more and more renewable generation into our energy grids, the demand for battery capacity to support these energy grids will go up, which means that the amount of batteries installed is only going to be keep increasing from now on. Now, of course, there comes a period where batteries lose efficiency. In answer to your small side question, no, there is no proverbial forever battery. Batteries are like any other thing in the world, limited to their lifetime. And so we are expecting that batteries today have a lifetime of somewhere between 10 to 20 years, optimistically speaking. And there will come a time where you have batteries going out of order and them requiring more maintenance or more replacement. Much like the repowering wave that is happening with solar PV and wind that was installed in the 1990s or early 2000s, which then are now being replaced. I think we're at the phase right now where batteries are increasing, so you have more batteries coming in, but we will know 5 to 10 years from now as to how those batteries are performing and how much of replacement, how much of maintenance we will need. But I think it is pretty much confirmed that grids will become more and more favorable towards batteries as we move into the future.
That's great, Kedar. But I have a very, very different view of the way batteries are working. You know, lithium prices, and I'm talking purely the lithium as a raw material that goes into batteries. Lithium prices are fluctuating. But over the last 10 years, we have seen that the cost of batteries, the final end product, which is the battery, is actually coming down. So what would you say? Why is it that even in an economy where inflation causes everything to have a higher price, the battery costs are coming down? Why do you think this is the case?
A brilliant question, Sahil. I think it comes down to the way you see the breakup of components in the battery, right? Each component has its own cost associated with it. And so for battery, you would have the minerals or the materials that go into it, along with the processing costs, the packaging costs, and all of that basically forms this entire manufacturing expense. And so over the past 10 to 15 years, you've seen battery prices fall. And the majority, or I would say even 100% of this fall is attributed simply to us becoming more efficient in the way we manufacture the batteries. So which means that our machines have become much better, our technology has become much better to process these materials, and we have just been able to manufacture these batteries in a shorter period of time. And that is what has caused this massive reduction in battery prices, somewhere around $150 per kilowatt hour today. But there comes a time where you achieve what is called as minimum manufacturing cost, right? There cannot be any more reduction in the manufacturing costs from that point onwards. And from there on, it becomes just a pure play of the component cost, right? Which is why we see lithium ion batteries today. I think they are at that phase today where the manufacturing cost has gone down to such an extent that the battery prices are purely dominated by the price of its component, which is then lithium. And therefore, we hear a lot of news going around saying that lithium prices are fluctuating, and so the battery prices are also fluctuating. Lithium has now become sort of like a commodity which then can be brought, sold, or held in order to manipulate the prices of the battery. And I think in the future it's going to be the same way, right? You have a new technology that comes in, it has a high manufacturing cost. Due to economies of scale and due to high demand, the manufacturing becomes much more efficient and the manufacturing costs go down. And then ultimately you're left with the component cost, which then dictates the way the prices of the technology move.
That was a compelling argument, Kedar. So what I picture is the prices of lithium ion batteries are falling. So it's like a negative slope. It goes on going negative, and after a certain threshold is where you cannot reduce the manufacturing cost any further. It starts becoming a bit flat. It stays flat for a while and then it becomes like a positive slope again. So it's like a valley and you're still coming down, but eventually we are going to hit a place where it's going to stagnate. And I assume that stagnation is where will then see the cost of batteries rising again.
A slight correction, we have already reached that phase right now. We have reached the phase where lithium prices are now single handedly dominating the prices of batteries themselves. And so we will see this component play an outsized role in the way the battery prices are then subject and then placed to users across the world.
while we are still looking at the way batteries are going to behave, cost of batteries are going to behave, can we just dilute a bit into the way the cost of mining of these raw materials are going to behave, right? Because we understand that these batteries are manufactured using rare earth metals which need significant effort on the mining front. So mining is also eventually going to be polluting. So again, batteries are feeding into our energy futures where we have energy security. But while mining happens, these batteries are also going to cause a lot of pollution. So are they really a better source for energy storage?
You're absolutely right. Batteries do have lots of materials in them, lots of minerals in them. These materials come at a steep cost when you're extracting them for the earth. Much so, the way in which it is extracted, using, let's say, for example, labor, and the labor situation is not too good in certain countries of the world, as we hear. So they cannot completely get free, right? You cannot say that batteries, oh, you're free to go, you're clean. No, they're not 100% clean. But in comparison to other energy sources, I think that batteries have a much less value of pollution per kilowatt hour or terawatt hour of energy stored and delivered. And in that sense of manner, I will say that batteries do play a key role. And coming back to our point earlier, it depends ultimately on the energy generation source itself. So when you're comparing to energy that is stored in a battery versus which is generated by coal versus energy stored in a battery which is generated using solar or wind energy, you will have a difference in terms of the lifetime emissions that have been generated. And so they are better in an answer to your question.
That was a very reliable answer, Kedar. I think it is very solid for all of us to assume that there is a flawless nature of batteries for the future that we are going to have. And let us all be optimistic with the way things are going to shape up. Can you also talk a bit about the energy side of things, like the electricity markets, in terms of where the batteries are going to play a role? So, if you were to connect electricity markets with batteries, and if you could talk about how the industries are going to actually make profits and run their schemes with their day-to-day supply chain, does battery have a significant role to play?
It's a very striking and thoughtful question, Sahil. And circling back to my point earlier, we've always known that batteries have a fundamental role to play, which is that status of the buffer that they adorn, right? But around it, you can build multiple other use cases. And that is what electricity markets help unlock. So, take an example. You have a battery, let's say, that can store 100 kilowatts of power over 1 hour. So, a 100 kilowatt hour battery. Now you have an electricity market where the prices of electricity fluctuate. Think of it like a stock market where a stock's price fluctuate. Electricity is the stock here. So you have during the daytime when you have a large surplus of electricity being generated by solar or energy being generated by solar that is then converted into electricity, which is then being traded in the market for $10 per kilowatt hour. Now you have a battery of 100 kilowatt hour. You can store 100 kilowatt hour, which then costs $10. So you're paying $1,000 in order to take this electricity from the market and store it into your battery. Now the day progresses, the sun sets, generation from renewables get low, but demand goes high because people are then coming back homes and consuming more. And so the price of electricity also goes high. Let's say the same unit of electricity that costs $10 during the daytime costs now $50. So now what you will say is that I have 100 kilowatt hours of electricity stored with me. I will then trade this in the market and get $50 per kilowatt hour, which is then $5,000 that I make from my battery. So I make a net profit of around $4,000 that day simply by choosing to store electricity when the price is low and this release the energy when the price is high. And this is one of the new ways in which batteries can be used by players, be it private or corporate, in order to make money or in order to make profits for themselves. Now, I will like to say decidedly, admittedly, that this is then bringing in a more economic value for the battery, which means that the fundamental reason for which batteries were developed, which is from an engineering standpoint of view, to act as a buffer, is being overshadowed. But I think it also brings a lot of positives with it in the sense that you are having more investments being made into batteries, which means that more innovation will happen and these batteries will then become more affordable and available to a larger part of the public.
Indeed. I think all of our conversations are just cycling back to this one aspect where batteries are centered around the evolution of human species, whether it be with the energy futures, whether it be with the electricity futures, or us going to another planet. Batteries are at either the forefront or at the center of this evolution. And I think that is how we should also positively look at batteries and the way the evolution is happening. But when we talk of an evolution, Kedar, we also have to have people who are skilled enough to support this kind of a technological upscale. Do we have that kind of a skilled labor who is knowledgeable enough to work on the batteries and, in case if needed, repair these batteries at a cell level? Or is there a huge gap in that space?
A very integral question. I think this plays a fundamental role in any technology as to how much of a skilled labor you can have to installing, to maintaining, and to supporting the further deployment of it. And I think the heartbreaking news when it comes to batteries is that we simply still do not have enough trained professionals out there on the field. I think it would be a bit gullible for me to say that we have an oversupply of professionals who can simply support the development and the maintenance and the upkeep of these batteries, because we don't have it right now. And I think part of the reason is that it takes time. Batteries are a new technology. They have been brought out onto the field and deployed in massive numbers over a quite short period of time. And although work has been done, and amazing work has been done on the research and development space and innovation space, I think not a lot of work has been done in order to promote younger generations or even experienced people to upskill themselves to be reliable technicians for maintaining batteries. And I think it's just a matter of time until when we realize that more batteries require maintenance, and at that point of time we will have this urgency. But now is the right time for governments to take heed, take notice, and already begin to start upskilling labor forces in order to be battle ready for handling this large influx of batteries and probably the different small issues that come along with it.
Profound, robust, and solid. I think all governments should kind of look at battery skilling as one of the very important areas of policy making, not just about implementing high quality as well as futuristic batteries. And if skilling is taken as one of the most important aspects of where the batteries are planned out to be, as you mentioned, I think there is a real potential for all of us as humans to evolve into a future where we are centered around very high potential batteries. But yes, while we talk about all of this, Kedar, I would again like to delve into a very parallel topic. You kept mentioning about various kinds of technologies within batteries, right? You mentioned about lithium ion. We discussed the cost fluctuations of lithium as well and how it is eventually going to stagnate, or we have almost reached stagnation. But what about the older technologies, the older unsafe technologies which are prone to catching fires, etc.? Can we somehow pull off the unsafe batteries from the roads across the globe?
A groundbreaking question, Sahil. And I think it would be a bit bizarre for me to say that yes, just pull batteries like lead acid out of the markets simply because you're having a liquid in it, which is then quite dangerous. It then reacts and it can cause lots of damage, it can cause fires. But ultimately, I think we have to come to realize the fact that these are the batteries that are affordable at the moment for a lot of countries that are developing, especially. And we cannot simply promote developing nations who have, in comparison to developed nations, a much lower GDP per capita to then say, hey, we're going to throw these batteries out, these cheaper lead acid batteries, and we now want you to buy more expensive lithium ion batteries or sodium batteries or any other technology that comes up simply because the people cannot afford it. And that is a grave, grave injustice that you're doing for such countries. And naturally comes the question, okay, then what do I do? Because ultimately it is these people who are then the most deserving of those technologies, these technologies which are then ultimately safer and much more reliable. These people are the majority of the people in the developing countries are the ones who need it the most. And how do we resolve this? I think it has to be a concerted effort on multiple directions by multiple different players in order for us to satisfy this equation. One, having technology players, having manufacturers focus even further on bringing down the costs of these new advanced battery technologies so that it becomes affordable. Two, on part of governments, on the part of regulators to sit down and come up with a comprehensive set of schemes and support mechanisms that help promote these batteries into the market and push the people toward buying it. And finally, three, up to the people themselves to see that yes, there is a technology out there that is not safe, and in its place, thanks to manufacturers, thanks to industry, thanks to government, there is now a new technology in place that is equally, if not more cost efficient. Buy it, use it, and then promote it through word of mouth or through other mediums. So I think there has to be an exceptional effort from the entire market or the entire economy or entire countries in order for us to take away unsafe batteries from the market, bring in new batteries, but still make sure that it is affordable. And then we will have a safe ecosystem and a much better quality of life.
Spectacular. With that said, I think Kedar, we had pretty marvelous episode. A lot of insightful discussions and a lot of wise conversations around the batteries, the future of batteries. We started around talking why do we have batteries in the first place. Then we talked about what are the different kinds of batteries, and now we came down to a conclusion of how various kinds of impacts are created by batteries on the human species as a whole. With that said, I thank you very much, Kedar, for giving your time for this episode, coming to this episode and sharing your thoughts. Thank you so much.
Thank you so much, Sahil. I think it was a joyful and a marvelous conversation that we had. Looking forward to more of the same.
For all our listeners, thank you very much for joining in. Be sure to share this episode with like minded energy enthusiasts, especially the ones who are interested in batteries. And don't forget to join the Perspective Club. For this, you should like and subscribe to our show on all platforms. And we will see you soon in another episode of the Crispy Perspectives.